Thank you for coming to my talk. My name is Vagif, and this hour we'll be talking about OpenTelemetry tracing and what does it mean for .NET developers. So I work for a Norwegian company, Miles. Last few years, actually last probably 7 or 6 years, I've been working mostly with F#, but like any .NET developer, I've gone my C# story, and all examples here will be in C#. So with OpenTelemetry, it's platform agnostic, it's language agnostic. You don't really need to think about which language you choose. But of course, it's easier if I present examples in C#. Who is familiar with C#? The audience? Yeah, everyone. So it should be a problem. But again, things, except for the demos which will be in C#, the rest is actually platform agnostic. This is also what is good about OpenTelemetry. So before we start going deeper, let's start with the beginning, the very beginning. So in the beginning, there were services and there were UI, and they were not observable. Like services that were completely without observability, they were void, and darkness was upon the face of the UI. So, and that of course was a problem. So God said, let there be logs. If you are old enough, you may recognize the face of the gentleman. It's a vocalist of the band AC/DC. And these pictures are taken from the official video, Let There Be Rock. So that song was about rock and roll, but we tweak it, twist it around OpenTelemetry. So there were logs. Of course, logs is the first thing you do to make things observable. That still was not sufficient. So the God said, let there be traces. And there were traces. And the world became way better with that. That still wasn't sufficient, and the God said, let there be metrics. And there were metrics. Let there be OpenTelemetry, God said after that. And at that point, probably the 3 first statements were easy. Okay, I don't need to convince you that you need metrics, logging, traces, but okay, why OpenTelemetry? We all have logs. You've been using Serilog or Log4net or anything like that with interfaces. You could easily switch log syncs. So is it just a new buzzword? What is it for us? So this is actually the purpose of this talk, try to convince you that there is something which we can actually adopt. It's worth adopting, which can give us great value in what we're doing, especially if we're dealing with distributed services, if part of our services developed by different teams, or maybe using different platforms. So in modern services, we have observability in forms of logs. I guess everyone does logs. Who does logs in one or different ways? Yeah, so almost everyone. Who does traces? Like where you can trace, track down the execution of your application. It's still maybe half, but less than logs. Who is capable of doing distributed traces? Impressive, but of course, fewer hands. And who needs metrics and who does metrics? Yeah, it's similar to traces, maybe. So this is logging. I don't need to explain much. This is from Elasticsearch from Kibana. This is our logs. And of course, you just describe the snapshot of your service or application execution. And the problem with logs that it may take you quite a lot of time to inspect and search for and build the context out of individual logs, because each row is just an individual snapshot of what happened at that moment of time in that service. Or maybe in many services, if there are several different services that logging here. So tracing in that respect is is better if you need to track down the sequence of events. You have a context here, so you don't really need to log much of context-related information, because for you it will happen. Some backend will have it for you big. Here it's tracing user Jaeger UI. It's a in the web browser, but this is not distributed traces. This is just one application. So it becomes more interesting when you have distributed tracing. Here you see there are two applications that contribute to tracing. There is web app, and then there is Q consumer. So the web app publishes RabbitMQ message, and this Q consumer reads a message from RabbitMQ. So this becoming interesting, and we'll actually we'll look at how you can enrich your protocol with support for OpenTelemetry, and we will use RabbitMQ as example. Of course, you have metrics. This is Grafana, one of the most popular dashboards for both logging and metrics and traces. So OpenTelemetry for observability, I was trying to find something that is easy to explain to a backend developer. And of course, we all work with databases. And then, okay, what can be really to grasp for that backend developer? I was thinking about NC framework, but then no, it's a bad analogy, because NC framework is not multi-platform. Well, basically also it's not multi-language. It's all built around C#. So then I thought that maybe bad analogy also good example, because this is you will remember that. Okay, OpenTelemetry actually is multi-platform and multi-language, so it's completely agnostic. But if you look at the history of developing various common standards for database connectivity, actually Microsoft, we're talking about like .NET, so we are in the context of Microsoft products. They've been doing it all the time. Like 30 years ago it came ODBC, then OLEDB with strange acronym, object linking and embedding for databases like ADO, ADO.NET, and then NC framework. So there's always been demand for doing common standard for that. So you don't need to think about details of Oracle database driver, about SQL server. And the same goes for OpenTelemetry. So you, until OpenTelemetry came, like with logging, we got this flexibility with logging interfaces. But when it comes to traces and metrics especially, we were locked much more to specific backends, to specific dashboards. And always it resulted that different teams made their own choices, and it was hard to cooperate. So what OpenTelemetry provides, it's first of all, it's a single vendor agnostic instrumentation library per language. So you have a language of your choice, whether it be C#, F#, Rust, Java, and then you have a library and those libraries, they produce something that can cooperate no matter what is your project platform. It's automatic and all manual instrumentation. That's also a very important point. We will have a look at it later. With like example of manual instrumentation is logging, when you need to write a log statement for anything that happens. OpenTelemetry gives you a possibility to turn on and off instrumentation for various protocols, like instrument all HTTP calls. And then you have it both on client and server side. Instrument all SQL Server calls. And then you can see the actual SQL statements which are generated, or MySQL if you want to. If there is a protocol that is not supported by OpenTelemetry, you can write something on your own. A single vendor neutral telemetry collector binary. So telemetry collects also by OpenTelemetry. You don't need to write anything for that. And it provides collection of telemetry data. You only need vendor-specific telemetry exporters. So whether you choose Elastic, application insights, honeycomb. Then, of course, you need something very specific, but of course, the telemetry providers, they give you these exporters. Telemetry data sent to multiple destinations in parallel, which means that you don't need to sacrifice your performance if you want to send it to different backends. And data collection is vendor agnostic. Finally, which is very important, context propagation for distributed scenarios is that if you have multiple services and they talk to each other, then there is a specification of how context can be propagated from one service to another. And it's done in a very efficient way. Basically, as we will see in example with RabbitMQ, it's just to enrich your communication, your payload with a couple of headers. You need to provide the correlation ID or like trace ID, or you need to provide parent ID. So it should be possible to find out who is the parent of that trace. OpenTelemetry also is a good case for application performance monitoring. If you look at services like Elasticsearch, like Honeycomb, application side, they all offer you some application performance monitoring services. So you can collect information about how your applications perform without need to build your own custom dashboards. And those data, like more and more providers of such services, they use OpenTelemetry to build this information. And this APM can be used to validate compliance with service level objectives. Here, NDC, one of the sponsors of NDC is Honeycomb. And you can, if you want, register free account at Honeycomb, which gives you some number of metrics you can collect every day. So it's enough to try it with relatively complex examples, and then they support setting service level objectives. So you can specify that you want that percentage of calls to be finished within that time, and then you will get a report about whether these service level objectives are met or not. And all this telemetry data collected using OpenTelemetry. Yeah, this is what more and more vendors implement. So this example of application performance monitoring dashboard from Elastic APM. You see, this is you get from Elastic. Of course, it's opinionated, so it's not dashboard that you have built yourself, but probably you're busy with other things, solving domain problems. You can more efficiently use your time than build custom dashboards. So you can get pretty advanced dashboards from different providers. So why did I personally start looking at OpenTelemetry? And that also explains why I've chosen OpenTelemetry tracing for this talk. Because we know that OpenTelemetry is not just tracing, it's metrics and logging. Well, first of all, logging is, probably if OpenTelemetry would be just about new standard for logging, it would be really hard to sell, because logging is like explored and generalized in pretty good way. So also, if you compare tracing and metrics, implementation of OpenTelemetry with traces, it has gone much further than with metrics. Both are still not like RCM version 1, but OpenTelemetry, and so you can still hit some breaking changes, but with tracing, we've been using it in production for quite some time. And of course, tracing is something, especially distributed traces, that we found really interesting in our organization. We really need that to trace across the whole organization, our services. So I was tired of investigating zillions of logs. And so logging was primary way of us to expose observability of our services. And whenever problem happened, then we had to search logs, basically, trying to find using some IDs, and that's not really efficient way of doing that. Also, we had to search through different dashboards because we have our organization is quite liberal. Like different teams can choose their own dashboards, they can choose their backends to a certain extent. So, okay, you have these services using that dashboard, this service using that dashboard, and then you have to actually search through multiple dashboards to find out what went wrong. And that's not the way to implement that. A good trace is worth 1,000 logs. Also, all services should participate in distributed tracing. That's the whole point of using OpenTelemetry for tracing. And services should be capable of collating trace data automatically. No longer these log statements entering SQL call is finished with that result, or HTTP client returned this. You don't need that. You should get it all automatically. Telemetry backends can be changed without revising code. That's also quite important point. So you use OpenTelemetry, you can switch backends, and you don't need to change your code, just change your configuration. And OpenTelemetry protocol used by APM servers. As I mentioned before, that it's quite important for application performance monitoring. So OpenTelemetry works with signals. And there are 4 main signals. It's logs, traces, metrics, and baggage. Baggage it's metadata which you attach to other signals. There is some confusion about terminology between .NET and OpenTelemetry, because .NET actually has had for a long time, for a couple of decades, something similar to what OpenTelemetry works with. So what is called tracer in OpenTelemetry, it's activity source in .NET. What is a span or telemetry span in OpenTelemetry is activity. And what is context, span context, is activity context. So it's easy sort of to memorize, but you just have to deal with that. So when you work with OpenTelemetry outside .NET, you will see like span context, and when you enter .NET in your application, it will be activity context. Just remember that. There is also, as I mentioned, what is really interesting with distributed tracing is to have automatic span creation. Then you can get automatically injected new segments of your distributed transactions depending on what you enable. So you start activity somewhere. For example, when you receive message from service bus or RabbitMQ, you start root activity, and then segments will be created for you. And you can do it for configure for HTTP client requests, for incoming ASP.NET service calls, gRPC calls, SQL calls, like you name it. Write your own. Messaging frameworks can be about tricky with automatic span creation. Like in our organization, we have 2 messaging frameworks, nService Bus and Akka.NET. Akka.NET has a commercial library which is called Phobos, which can be used to automatically create telemetry spans. What we found with both of them is that because of the nature of message processing, especially with, if it's actor-based system, you can end up with quite a lot of segments. Because typically with actors, you have like single responsibility. Actors are typically very, very small, and each actor works just with one thing. Received message, did some work, sent further. So it's like it's similar to like having created telemetry data for a class. So you can end up with quite huge number of segments for your distributed calls, which is hard if in distributed scenario if you have multiple services from the whole organization participating in distributed transaction, and then suddenly you have like 1,500 segments from your tiny service. So we worked together with Akka team, and they actually made changes or additions to the Phobos library, which supports now 2 modes of creating spans. Like you can have full control of that. You can say, okay, this is my business transaction. I create spans here, or you can let library does it. Then it's still interesting, for example, to solve some performance cases. So how do you start with OpenTelemetry in .NET? Of course, with .NET, when you start with new technology, it always you start with adding NuGet package. So there is go to nuget.org and then find OpenTelemetry. Search for OpenTelemetry. You will find OpenTelemetry NuGet package. That's basic to add OpenTelemetry support for your application. Of course, it will give you no output unless you include some exporters. So add some more packages. If you want to see all traces in your console, add OpenTelemetry exporter console. Add Prometheus if you want to use Prometheus as backend, and so on. Then, in addition, if you want automatic OpenTelemetry data creation for various protocols, you should also add packages for those. OpenTelemetry instrumentation, HTTP, OpenTelemetry instrumentation, SQL client. Those are instrumentation types of OpenTelemetry packages. And you can then activate them, exporters and instrumentation, in a bootstrapper. In the same way like you bootstrap typical ASP.NET or Windows Service application. So where do you search for OpenTelemetry exporters and instrumentations if you don't find something you want to have? Start at OpenTelemetry.io. This is sort of platform agnostic entrance to OpenTelemetry. You see here both Java and Go and .NET and JavaScript. And then from there you can go to OpenTelemetry.NET project, and then you will see what is available, and you will see that there are some basic things available like in-memory, Jagger, ASP.NET Core, HTTP Listener, and Zipkin, and so on. gRPC, SQL Server. And then there is a huge list of OpenTelemetry collector contributions. Those contributed by open source developers. So most likely you will find something for you. If you work with something esoteric or specific, you can probably write your own. We will have an example. It's not really hard to add your own support for OpenTelemetry for certain protocols. So check GitHub, of course. GitHub is also a great place to check these things. Check vendors repository. Honeycomb, they have open source package for OpenTelemetry in the GitHub account. They also publish it on NuGet. Datadog, excellent support for OpenTelemetry, though expensive. They have something there. Like MySQL, for example, there are several MySQL providers for drivers for .NET. If you use MySQL connector, that comes with support for OpenTelemetry. And write your own. So vendors who support OpenTelemetry, it's I made this list a couple of months ago, and then I'm sure it's much longer. Well, it's not the whole list. It's just a few that probably you will recognize. Something like Azure, AWS, Elastic, and so on. And the list is, at the time when I looked at that, it was probably like 3 times as large. Now it's even larger. Just for your information, we started with using Elasticsearch. We were not completely happy with the way it presented distributed transactions. Also, we found it was not very stable for complex scenarios, and took some time actually to present distributed traces for where multiple services were involved. Application sites works well. Costs, it can be quite expensive. So we consider currently Grafana Tempo, because then you can build it on the top of your own storage, which potentially might give you lower costs. And Grafana is a great dashboard. So now let's have a look at how you can instrument .NET application with OpenTelemetry. So what we're going to do, we will look at bootstrapping, how you bootstrap application, how you can add exporters, instrumentation, telemetry sources. Then we will have a look at how you collect traces in a single application, just small console application. Then we go from single application to distributed scenario where multiple applications are involved. And then we will look at more complex scenario, how you can actually have your own custom trace propagation. And we will use RabbitMQ, which is a popular queuing library. Who is using or familiar with RabbitMQ? More than half. So that probably should give you confidence in if you have worked with something that don't have support for OpenTelemetry out of the box, you will see how easy it is to add it. Okay, so with that, I'm going to Rider. What about fonts? Is it sufficient to? I don't want to make it very large because then we will see. But should I make it a bit larger, or is it okay? Okay. Mm-hmm. Okay. So what we will be using here? So this is. Okay. Let me see. So we have. Yeah, let me find Docker compose file. Yeah, so this is Docker compose file. I'm using Docker here. So we have MySQL, we have SQL Server, we have RabbitMQ. So it's all just so we can run everything on my Mac, and we'll be using Jagger. So this is Jagger UI. Yeah, so I can find some traces. Yeah, now it's empty because I tested it, I tried it before when I was rehearsing this talk this morning, and it shows me by default for the last hour or something. So now it's empty. So we will start first with a very small console application where what it will be doing. There is a list of words. Quick brown fox jumped over the lazy dog. And then it will create recursively to make it more interesting. So we have like nested traces. It will start activity. So we always need to start activity like as a root activity, which will start distributed trace. So it will recursively start activities for each new word, and then it will set tags, count and word. Then it will delay some milliseconds, so we will see like activity that will have some length, and it will continue. And I think we will run it 10 times. Yeah, it will run 10 times. So let's try that. Okay, and there is not much of. Yeah, there is a very little configuration here. We add SDK create trace provider builder. This we have from OpenTelemetry. We have to add source. So we have to enable what sources write to OpenTelemetry so we can switch them on and off. Then there is a set resource builder. It's I will understand that it's from service. It's like also like another way of saying adding a source. Then you have a Jagger exporter, so we want to export to Jagger, and we want also to export to console. So all that we're going to be produced, we'll see on the console, also will be sent to Jagger exporter. Also, if you have a Honeycomb account, you can also use it. I will not use Honeycomb in this demo, but the output is quite similar to what we will see in Jagger. So let's run this application console up, run. Yeah, so it displays something. Yeah, and you will see we have it something on the console, activity ID, duration, so on. But of course, there is not much to see. It's better to search console. Yeah, we have 10 traces. And you see that each trace has 8 spans. So if we open these spans, this is distributed transaction. Oh no, this is just trace transaction, not distributed yet. So if you look at tags here, and it has count 2 word fox. So we enriched this trace segment with some additional information. And because we made it recursively, then now we have this trace which consists of 8 segments or 8 telemetry spans if it use OpenTelemetry language, or activity, or what is called activity span for .NET. So, but everything we did manually. So it's not distributed. It's all created manually. It's sort of, we have it as a proof of concept that it kind of works, but we want something which is more interesting. So next step, we go to web app. So we have a program, and then the same thing that we want to get this sentence about quick lazy fox, but from the database. So you see here we want also show now some automatic span creation. So we have add source message public, that's for message queuing. We have ASP.NET Core instrumentation, we have SQL client instrumentation. Different vendors may have different syntax for specifying how to add their instrumentation or their source. Like for MySQL, you need specified add source MySQL connector, while for SQL Server, it's add SQL client instrumentation. So it's a there is no sort of standard agreement about how they do it. Most of them have some extensions method, so you can have some add XXX instrumentation, but not all of them. So we will not be using MySQL. I think we'll be using just SQL client. And of course, our exporter is still Jaeger, Honeycomb. You may have, and also console exporter. So what application does, it we have a, here we have a choice of backend, but basically it's a website using minimal API. So you have /reset, you start from the first word, and then you when you /word, if you write, then it will increment word index and then get things from the database. So let's try to run it. Okay, stop and build, stop and run. Okay, okay, we are in reset, and then if you try now, word, quick, brown, fox, and so on. Yeah, so let's see how our Jaeger will look now. So now we have a hotel web app, find traces. Yeah, actually I already have it distributed because when I was rehearsing talk, I started OpenTelemetry Queue Consumer. So what this application does also, when this web service, when it gets word from the database, it also sends it to RabbitMQ database. So we have it here. So if I stop my Queue Consumer, let me see where is that Queue Consumer. Let me stop it because I want it for a different demo. And then we try again over the lazy. Then I go to Jaeger and then web app, find traces. Yeah, you see, the 3 last traces are not distributed because Queue Consumer wasn't running. But we have now automatic creation of spans because in the application code, we basically just set up our exporters, set up what extra instrumentation we want to send to OpenTelemetry, and that's it. And then what we did, we enable ASP.NET Core instrumentation, we enable SQL client instrumentation. So if you look here, this is /word. So we get it from our web app, and then you see that the HTTP method get. So all this is coming automatically, collected for us by OpenTelemetry without us doing anything. We just enabled it. And if you look at, I think this one is, or maybe before that. Yeah, this comes from SQL server instrumentation, which we enabled. You see, here is the SQL statement that is executed. So also, this is collected for us by OpenTelemetry. What we found is that it's good for like in the initial stage to collect everything. Then typically you don't want that level of instrumentation. Like of course you only need SQL statements for you to be collected if you're dealing with some problem with SQL database. But for demo purposes now, and also as a proof of how easy you can get instrumentation on each level you need, that works pretty well. So, but it's not distributed yet. So to make it distributed, let's, because now what we were doing, we were manually sending through browser some requests. So now we have web app client. So let's run it, which will run several times for us. Jagger UI, web app, find traces. Yeah, now we see there is distributed traces here. It's web client and web app. So if I open the trace, I have here my web client with some additional data. Here for web client, I enable automatic HTTP client instrumentation. So it sends telemetry data for HTTP requests. For web app, I enable ASP.NET Core instrumentation. So it's different type of instrumentation which I enabled. But as you see, the traces are built from this data. So it goes to web server and so on. And here are my tags. So what, again, as I mentioned before, it's just a couple of headers which makes it possible to correlate this data. What kind of headers? We will see by looking at RabbitMQ. Because what I did, I stopped QConsumer. And I'm running from Docker container RabbitMQ on my Mac. So what happens now, my web application is actually sending every word which it reads from the database to the Rabbit. So actually what I can do, I can expect this queue, and I can get messages. Let's get a message. Yeah, and that's you can see that the actual payload is quite small. Okay, do I have it? Yeah. So this is over. This is a word. But there are a couple of headers which are sent to the RabbitMQ. Here, there is a trace parent and there is a correlation ID. So that's sufficient actually to build open telemetry traces. So when we collect these messages from the queue by running QConsumer, it will recreate OpenTelemetry distributed context. It will propagate it and will continue. So what we're going to do now is that we will start this OpenTelemetry QConsumer, run QConsumer. Yeah, I think now we probably will see that there are no messages, queue messages. Interesting. Oh, yeah, now it's 0. And if we go back to Jagger, actually I don't know how to pronounce the name. Jagger or Jagger? Any tips? Because I'm sort of, because I work in Norway, and then in Norway it's Jagger. Jagger, okay. Yeah, so search, web app, find traces. You see, we didn't send more messages, new messages, but our traces, which only had two services, now they have extra segment, and there is queue consumer. So if I open this trace, there is a queue consumer here, and then you see that it happened somewhere there, because I was talking, describing things, and then so now the original trace segments, they are somewhere here, and then this came after a few minutes. So basically, as long as you have data in your backend, as long as they are not deleted, if you have a message somewhere in service bus in a queue, and then you collect this message in 1 year, your distributed trace will be enriched, will be extended. So this is also a powerful thing, and then so your distributed, it's very easy to build distributed traces, and you just need to agree with the whole organization, with all the teams, what backend you use, and make sure that data stays long enough to build interesting traces. But most of the traces, of course, they're built using some seconds, minutes. In our organization, it can be hours because we deal with media files. What we do is we upload media files, which can be like tens of gigabytes, and if they are stuck in transcoding, if they're not sent further for further processing, it may come with some delay, and this is interesting to explore, and this is one of the reasons we started working with OpenTelemetry. But how do we achieve that? Okay, we have RabbitMQ, which is not supported natively by OpenTelemetry. So what does it take to make it OpenTelemetry ready? We need to do two things. First, we go to my message sender. Let me find it. Yeah, message publisher, MQ publish. Yeah, when I publish a message, I need to use call propagate inject. I need to let OpenTelemetry know that, okay, this is use distributed context propagator and inject some additional data. So what I pass there, I need to pass some callback there. And my inject trace context. This is a callback which will be called by propagator. Typically, it's a key value, so it's a dictionary of things. So I use what I use here, message properties header. So it's Rabbit headers. What I do in this callback, when distributed context propagator will call me and say, okay, I want to extend my distributed trace or your distributed trace with some additional data, it will use Rabbit message headers as a transport to send them further to the consumer. But of course, I need to, and this is what we saw in this RabbitMQ headers. So they are injected here. And in my queue consumer, I need to do the opposite thing. No, it's message handler. It's that one. Activity source propagator. Yeah, I have trace context propagator, and then when I execute it, when this happened, extract trace context. So basically does the opposite thing. Here are RabbitMQ headers. Try extract these values, and there are two values. It's parent ID, it's correlation ID, and then it builds the context and it continues. If it can't extract it, it will create a root distributed trace, starting a root segment for distributed trace. So the new distributed trace will start there. So let me go back to play from current slide. Yeah, so that was about how you start with OpenTelemetry. A few words about what we do in our project. I mentioned that we use the actor model, we use akka.net, and with akka, there is a protocol you need to enrich. A neighbor team using nService bus. For nService bus, Jimmy Bogart, who is here in this conference, he wrote a NuGet package that it's open source, it's free, that you can use to extend nService bus communication with OpenTelemetry. With akka, it's a commercial library. It's called Phobos. It supports both metrics and traces. And as I mentioned in the middle of the talk, that we first used this default way of creating traces for actors, and then you see that here this messages if messages if messages. So this is typical how work with actors. Like actors send messages and new message, new message, new message, and that's that was not something which was easy to work because of granularity. Like you have 1,500 messages for your business level transaction. So we worked with Akka team, and then they came with new version of Phobos library, which was just released, version 2.1, where these are much larger business units. So this is basically uploading a single file. Each TV program consists of 5 or 6 media files. So here goes uploading, and we control it ourselves. So these are uploading files, and these are messages, events that we get from the origin which receive this file. So for every business level transaction, we have something like maybe 20, 30 such segments in a transaction, and then we can ourselves decide what we need. For example, we can cut down on these events if we only need to investigate time of upload files. So it's now we are in the process of inviting other teams to join forces. So we want to build distributed transactions that include other services. But as I mentioned, that if you use messaging libraries, you may experience that situation that your automatic segment creation will be give you too small, too short segments for you. So I'm coming to the conclusion of my talk, and then what I would like you to bring the takeout from the talk. Rethink your logging strategy, first of all. This is how we started going towards OpenTelemetry. Are you logging too much? We've been logging sometimes tens of millions log entries a day, and that's too much to explore. And 99% of it just waste, because when things going fine, then you don't need them. Can small amount of traces replace huge number of logs? So yes, traces are much more informative because they give you context, and especially if you have distributed traces, then you have a single source of information when you need to investigate what happens to your business transactions. So find a suitable OpenTelemetry backend dashboard, and what we found out that it's not just qualities of like how nicely dashboard looks. Running costs are very important, because some backend, some providers can be very expensive, and they give you much more than just OpenTelemetry. So you need to find what costs are sufficient for you. Also, part of that is do you need application performance monitoring? You can get a lot of that from your backend, from the vendors which you select, but they're quite different, quite opinionated, the way they build application performance monitoring. So use some time and investigate whether or not it will fit you. So I think we still have time for some questions. Yeah, if you have any questions, objections, observations, please shoot out. Then question from me. Are you interested in, do you think that there is a place for, in your projects to try OpenTelemetry? And if you don't, like, why? Can anyone, who thinks that there is a place for OpenTelemetry to try? Majority. Who is not sort of convinced and think that there are some, there are some struggles with that? Mm-hmm. Okay, that sounds promising. Okay. Yes, so then please enjoy the rest of the conference, and I'm still here, so if you have any other questions, like private questions about your projects, then I'm available. Thank you very much.